All right. So, are you able to hear me clearly, everyone? Hi. Good morning and good evening to some. Great. Great. So, let's start where we left yesterday. So, can somebody quickly help me where were we yesterday? All right. So, we discussed the word count problem and then we also discussed about more about just a second. I will have to turn off my phone. All right. So we were here. We discussed about how does the group by work and why we should use reduce by key instead of group by key mostly. All right. Any questions at this point? No questions? Okay. Okay. So I'm assuming that the silence means no questions and we'll continue the great. All right. So there are some more operations on RDD which are very useful, and some of the transformations and actions are very very useful. And whenever you are building your product, whenever you are working on your project, you will need to understand what all is possible, as well as what all could be, how would you accomplish something. Okay, so sometimes you have to combine elements of by the key. Okay, so there were, so far we have discussed two things. One was reduce by key and other was the one was reduce by key and other was group by key. Okay, while uh, reduce called your method again and again on all the values for a particular key. Group by key gave you the iterator to all the values for each key. Okay. Now, Sometimes what you want is when the so combine by key is more like reduce by key, just that the reduce function has been broken into three parts. Okay, you can use three different function for three different kind of reduction. Okay, for example, when you are combining when you are combining. Okay, let me take a step back. So what did we do in combining the values in case of reduce by key? This is a little important because this is little difficult to express. So I'll try to describe it. So when we reduce things, right? So there were few points you must have noted. Okay. So in case of reduce, you had these two values, say a and say 1 and 2. And the result of these, so our reduce function will take these two values at a time and give out something. Okay. Now, what will be the data type? What will be its data type? Can anybody tell? We are talking about reduce function. Okay, so in case of reduce function, we take two values and apply our reduce function on those two values, and the resultant, whatever is the resultant, will be combined together. Okay, this whatever it comes here will be combined together to reach to another value. Okay, now if there were 1 2 3 which is integer, okay, what will be the data type of this output? Anyone? So your reduce function takes parameter like two integers. What will be the return value of the reduce function? Will it be same as the arguments it is accepting? I agree, Hiren. It will be one value. That's totally agreed. So its data type, will it be same as the arguments or will it be different? Can its data type be, say, string? The return value of the return value's data type, can it be a string? Okay, let's take an example. Let's take an example of my function. Let's say f, or let's say minimum. It takes x and y, and what does it? It takes two integers. It takes two integers, right? And what does it return? So now, in the next run, this value will be the input to the same reduce function. That means it has to be same as the input value. Meaning, if our reduce function applies on two integers, the output will also be an integer. Right? Do you remember that? These were the few trivial things to notice about reduce function. Gaurav? Okay, so let me ask it in another way. Let me ask it in another way. All right. Okay, so let me ask you this way. A reduce function takes two argument of the same data type. Agree? Yes or no? Yes or no? Gaurav says yes. Mandy says yes. What about you? Jitender? Hiren? Alright. So let's just rectify this first. So if we understand, let's say, let's take a case, okay? Some of you are not agreeing that the answer is yes. Let me try to first clarify that. All right? Because that's far more important than rest of the things. All right. So if you remember correctly, it took two values. Okay. It took two values. Let me just draw two boxes. These are the two boxes. These are the two values which it will take as input and give certain output. Okay. Now if we have a third value as well, okay, so third value will be combined after after we have received the value in the previous go, right? Because it's the same function, okay, being applied again and again, right? Now in case of reduce function, these two arguments have to be of the same data type. Otherwise, it will never be able to figure out which one is X, which one is Y, because you don't have luxury to choose that which is X, which is Y. Okay, so it takes this two data types of the same value, because your reduce function is being applied again and again on an array of values which have the same data type. Okay, because let's say there is an array in which you are alternating data type. First one is a string, second one is an integer, and third one is a string, and fourth one is an integer. Now when you try to combine such data, you are not sure which argument, first or second, will get the string, or first or second will get a number. Therefore therefore both the data types have to be of the both the arguments have to be of the same data type. All right. Does it make sense here and now? So okay. Alright, so here a reduce is working on an array of values. A reduce function is such as, for example, let's say reduce function is minimum x or y, and this is what you have defined. If x is less than y, return x, otherwise return y. Okay, this is our reduce function, for example. Now if you have an array of values, if you have an array of values and you have to compute minimum of this using hundreds of machines parallelly. Okay, there are say 100 billion entries. Okay, so if you have to compute minimum of these values, what will you do? And this is not ordered. This could be say 100, this could be 20, this could be 12, this could be 30, and this could be 14. Okay, so this is not sorted. So if you have to compute the reduce of this one, what will you have to do is split it into, let's say you have 100 machines or 100 cores, let's say. So what you will do is you will take this data, this is your data, you will parallelize it, and okay, you have, this is your RDD, you loaded this data onto your 100 machines parallelly, and you may say here that make 100 partitions, or maybe say 500 partitions, because you have 100 machines, say each might be having 5 cores on an average. Now this RDD what you have just generated, you could do kind of a reduce on this. You could reduce, okay? Reduce by key and reduce functions is the same thing, just that when you say reduce by key, it expects the data to be in key value pairs, okay? It could be something like something like a key value pair, okay? Something like A is this, and again it's the same thing over and over again. So let's say for key called A, there is this, all right, like this, all right. So maybe there are more values for another key called B. But when we are reducing, when we say reduce by key, when we say reduce by key, what exactly happens? Or let's say here you are defining a function, defining f, which is uh, let's say min f, right? So you have defined a function called minf, you're passing it here. What goes on inside it is first, uh, so so what would happen here is the values, the various elements will keep on grouping together, and reduce will keep on happening, okay? For reduce, when we say reduce by key, what would happen is for all the values for a key called A, okay, your all the values of reduce, all the values for which the key is A, all the values will be considered like an array, and again your function will be called. So key will not be visible, key will not be visible to your function, okay? So for example, your minf will be applied on 120. Whatever is the resultant, then that will be combined with 12. Whatever is the resultant, that will be combined with 30, and that will happen parallelly on all machines. Okay? So key is not visible to the reduce function. Make sense now? So it's different from what you studied in MapReduce of Hadoop MapReduce. All right. So this way, this is the difference between the all right. Now, one more thing to note is that this process, because the moment we say parallelize, what happens is that this gets broken down into multitude of arrays like this. Okay, parallelly. These are called partitions on multiple machines. Okay, and when it gets broken down into various partitions, when it gets broken down into various partitions, so the grouping as well as, so whenever say we say reduce by key, the process is happening independently on all the machines, okay? And when we reach to a conclusion that here for A the minimum value is 12, here for A the minimum value is 5, and so on, okay? At the end of it, again, all these values will be combined together using the same reduce function. Okay. So first, on all partitions, the minification will happen, or you can say reduce will happen, and then all the resultant of all the partition will again be reduced by the same function. Okay. Now that was the reason why two arguments have to be of the same type, because you never know in what order your function is going to get applied, so we cannot have two different values. Okay. The other question which I wanted to ask is the return type of a reduce function same as the data type of its arguments? Yes, because it has to be applied again and again. So for a reduce function, the data type has to be same, because the resulting result of two values will be combined together with the third value using the same function. Therefore, it has to give out the data type which is the same as the other values. Okay. All right. Now, so everybody says yes. Now, next question to all of you. Uh, so, whenever we are doing reduce by key, the resulting value is same as the input values. So when we are, for example, here we are trying to do group by, okay, reduce by key. So the data type of the output, what we are expecting for each group, the data type of the value for each group will be same as data type of the value in the input. Is that correct? Okay, herein I will come to that. Yes. Now, sometimes that's not what we require. Let's take a simple case where we are trying to concatenate the values. We are trying to concatenate the values, or our resultant value is slightly different from our input value. Okay? So in those cases, sometimes we want different things. Sometimes we we want to differentiate between the the reduce happening on the actual input and reduce happening on different inputs. Okay, so I will come to this again. So sometimes we want that our output may be different. For example, let's say we want to concatenate all these values together. Okay, when we are concatenating all these values together by using the reduce function, what would happen is the resultant would be of different data types such as string, and therefore we cannot use the reduce function, although it looks like that the reduce function is meant for similar role, but we are not able to use it because of the data type issues. So we break down the reduce process in the following manner. Okay, we break down the reduce process in the following manner. First, we designate something called initial value. Okay, we designate something like initial value. This is our initial value. Okay, this is a dummy value. Okay, dummy initial. Okay, these are the actual. So this is a dummy designated. We designate or we pass this value in argument that this is our initial dummy value. And here, these are our rest of the data. Okay, this is our rest of the data. All right, so you can see here, this is our rest of the data. And what we do is we first combine these two values. Instead of combining first two values together, we combine the first value with the dummy initial point. Okay, now let me just change its color to something really different. Okay, so now there are three kind of operations which are happening as of now. Okay, or let me just go with what we have in plan. So let's say we want to convert our data type from this kind of RDD. Let's say our RDD has the key is of K data type and the value is of V data type, right? And we want to convert it into another RDD using reduction into key comma C. Okay, new data type. So V is not same as C. That was in case of reduce. So for having such scenarios where our output value is different from the input value, it has got different data types. In such scenarios, you use combine by key instead of reduce by key. Okay, you use combine by key instead of reduce by key. All right. So first, to get it done, we will have three functions. First function called create combiner, which turns V into C. Okay, which converts V into C. Or let me first go back to the same drawing. Okay, uh, let's not have initial point. We'll discuss this initial point thing again. That's another part altogether. All right. So there is this function. Let me just mark it with the same color. So these are your input values, and you want some output value. Okay. So first you convert your C. This is your C into V, and there is this function here. All right. Now there is another function which takes two arguments, one of type V and another of type this, and converts it into again C. Okay, I'll try to color code it. All right, so there are two different functions. First one converts your value into C. Second one takes one C and one V and converts it into C. Okay, now there is third one which combines two C's into one single C. Okay, now imagine this, that the same thing is happening again and again, and there could be another C, this coming from somewhere, say from somewhere. Let's say this is another partition. All right. This is another partition, for example. All right. Now these two values have to be combined together. Okay. These two values have to be combined together, and the color will be red for them. And you have the output. All right. I think this describes well. All right. So what exactly is happening here? We want yellow instead, and our data type input is of blue. Okay, these are our data type, which is of blue, and our resultant we want yellow. Okay, these are the different data types. All right. So first, the way this reduce mechanism or this combined mechanism would happen is it will take one of the values from your data set. Okay, from each partition, this will happen parallelly on each partition. It will pick one value out of this, convert it into yellow. I hope it's yellow because I'm a bit colorblind. So first it will convert it into yellow, and then the another blue will be combined to yellow and convert it into yellow, because at the end of day we want yellow to be the output. Then there will be another function. Say this is another partition. Let's just imagine this is another partition. Okay, this, how can we, this is, let's say, another partition. Okay, this is partition 1, this is partition 1, and this is partition 2. Okay, now if you notice that the same process will happen in partition 2 as well, and the two yellows coming out of the different partitions have to be combined together. Okay, so now you will notice that there is one function which takes only one argument of type blue and converts it into yellow. Now there is another function that takes one argument as yellow, other as blue, and converts it, returns a value as yellow. Now there is a third function which takes two yellows and give out yellow. Okay, one takes blue and gives out yellow. Okay, and second one takes uh, one yellow and one blue, gives out yellow, and third one takes two yellows and give out yellow. Did I make sense? I will take a real example after this. I believe that colors are easier to understand. Therefore, instead of numbers, I'm using colors here. Gaurav, Hiren, Mehndi, Jitender, Ashish, Ishwar. Therefore, there are three different functions which we require. One, this kind, this kind, which takes only one argument. Okay. Second, this takes two arguments, and the third one, which takes the two arguments, one is of blue type or other argument is of yellow type, and the third function, red one, takes two yellows and give out yellow. All right, are you comfortable with me? All right, this is partition 1, Okay, this is happening on partition 1, and this is happening on partition 2. Okay, so let's make this yellow as string data type and blue as our say blue as our what do you say, integer data type. And let's say all we want to do is concatenate all values by comma. Okay, it's as simple as that. Our objective is to concatenate all these values by comma. And when we concatenate value, then all right, let me just save it inside the slides itself. All right, let's say that what we want to do is we have numbers like we have 1, we have 2, and we have 3. All right, and we want to convert it into something like a 1 comma 2 comma 3. We want to concatenate all these numbers using reduce method. Okay, so first word would be that 1 would get converted, and we cannot use a reduce function to convert it into a string. Okay, reason being that reason being it's not possible because our reduce function does not allow us that to convert to give out different data type, because this is string, this is a integer. Okay, so what we do in this case is first we write first function, and what does this function do is it just convert it does strx. And if you remember, since we cannot concatenate the two values integer and string, therefore we would require three different functions. Okay, so first function will just convert one into a string. Okay, so it became a string. Second function will take these two values. Okay, one is string and other number. One is string and other is number, and it will one is string, other is number, and it will convert it into concat, as in say this function here will, where should I write its code? Say here the function, what it does is it says a plus a string of b, where a and b are two arguments. This is a, this is b. So here we will get 1 comma 2. Okay, I'm using double quotes to represent a string. All right, similarly the same process would happen here as well, and this will become 3. Now taking two of these, we can further concatenate it, just like this time we don't have to cast anything. All we need to do here is a plus b. So we have three different functions. First is strx, other is a plus strb. This is str, let's just say a. We are assuming that there will be two arguments called a and b. Okay, so here this is a, this is b, and we'll concatenate them in this following manner. Why are we using strb? Because we cannot say simply a plus b, because b is a integer, a is a string. So we'll get a plus b like this, and then we go forward and reach there. So we have three functions. First one str_a, second one a plus str_b, and third one is simply a plus b. Sounds good? Are you with me, or have I completely lost touch? All right. These are very important to understand because these are the crux of the distributed computing. Although these are very easy things, okay? It's just that we have never thought that concatenation would be such a big deal. All right, sounds good to you? Now let's take an example here. Here, let's take this example, what we have done here. Okay, I think this will not work. So let's say we have defined our x equals to sc dot parallelize, and our there are three elements in RDD, and each element is of type key value. So when we try to say combine by key, when we say combine by key, what would happen is the values for a, which is 1 and 1, would come together. And let's say all we want to do is we just want to concatenate these values together. We don't want to sum up, we just want to concatenate these values. Okay? So what we do is first we write our function converts which converts a number into a string. Okay, which converts, so we create our create combiner which turns v into c, okay, which is converting into a string. Let's define that. And this is okay. All right, so let's just define this. Okay, it will convert it into a string. Done. All right, second function will take two arguments. Okay, two arguments a and b, and we'll convert a plus string b. Remember our diagram here, a plus string b. Okay, so a plus string b, fine. And second one's objective would be, this third function that we require, which will take two arguments a and b and just concatenate them together like this. Okay, oh sorry, I'll have to give a different name. So we have three functions. One is called f, other is called add, and third is called add1. Okay, so what does add do? So what does f do? I've just given them arbitrary name, don't worry. So what does f do? F converts an integer into string. Okay, second one, the add, what does add do? Add basically takes an integer, in string and integer, and then combines them together. Okay, it converts the second argument into string and then concatenates with the string. The third one, all it does is add 1 here. Okay, so it takes two string A and B and just concatenates them. Okay, although even if we casted it again, even if casted the B again into string, the casting string into string is not a big deal. Okay, therefore we could use this function as well, but let's just, for argument's sake, let's keep these three separate functions, right? Now we go back to our x again and say combine by key. Okay, first is f, and let's just go back, merge value, which is v and c into new one. Okay, which is add. The third one is combines two c's. Okay, which is add one, and we'll talk about the partitions later. This is our, say, new rdd is being created out of it, x1 dot collect. You can see that the values have been concatenated. Okay, of course, since our function did not put comma in between while adding things, we got this. Okay, so here you can see that this got combined, these two values 1 and 1 got combined into 1 1, and it's a string. Sounds good now, Gaurav? If you have any doubt, you can I can repeat the whole process, because it took me, when I looked on these things, it took me fair amount of time to figure it out. Okay, so it's not a very obvious thing. All right, so that's how you get different data type than the input data types, and this is another mechanism, add-on. It's a kind of a new extension of reduce function. Okay, sounds good. Now this is a difficult one, so who can help me with this? So there are three functions: cc, mv, and mc. Cc is create combiner. Basically, it is for any value v, is putting square brackets around. Yes, Gaurav, you have a question? All right, let me repeat. What is the fourth argument of create combined by key? Okay, so fourth argument is number of partitions. Okay, you can specify that how many partitions you want in the output, because it will be reorganizing it, and you can tell that after you're done, create these many partitions for the output. All right, great. Now moving ahead, this is an interesting one, and you'll like the output. Okay, so here there are three functions. One is cc. Okay, and the way I have kept names is in the same way: create combiner, merge values, and merge combiners, merge combined outputs. Okay, all right, so I've created these functions. First one, what it does is it takes two square brackets and encloses the value inside. Okay, what it does is this. All right, yeah, okay, it converts the value into tuple. Okay, this is basically converting a v into tuple. Okay, let's see what happens when we put say bracket, one and a square bracket here. This is just a string, okay? We could also put things like this, and then my value say 100, and then say x, okay? So we could create a tuple like this, and that's what we are doing here. Here also we are putting just the square bracket for the fun sake, and that's what we are doing. All right. So the create combiner part is basically creating a tuple out of a value by putting two more elements around it, and this one is left square bracket and other is right square bracket. Okay. Now, second one, what is it doing is it's taking the the values up to the last element, which is till here. Okay, then uh, uh, so it's taking it's removing the last element from C, then adding value V, and adding a right square bracket. Okay, and the third one is basically removing the last element from C1 and first element from the C2 and then concatenating them. So what will be the output of this one? Anyone? So CC will take the first argument as 1. This is numeric 1. And then MV will take the output of CC1 and then put it with 2 and so on. Okay. So what will be the output? Can somebody guess what will be the output? Not clear? Or do you want this code? I can send you the code. Yes, anyone? Yeah? So you want me to define it? Let's say we define this function. Alright. So what will CC10 give? It'll give us this kind of thing. Okay. And let's say we save it in a value called x. So x has got a tuple which has three elements. One is left square bracket, second one is an integer which is 10, and third one is the right square bracket. Alright, brilliant. Thank you, Gaurav. Anybody else? Ishwar, Hiren, Mehdi? Jitender? Alright, so this is what we have done. And now let's see what is the output of MV. MV's output is, let's say we put X and we put 20 here. Now you see that? So it has created a tuple by combining this tuple and this tuple, by removing this one and putting 12 and right square bracket. Okay, and let's say we put it again in x. Now we have got x as this, and next thing we do is we, let's say there is a y as well. Okay, let's say y is there. Okay, okay, so we have got x is this, y is this, and now let's say y is something like 200. Okay, we have got x is this and y is this. Okay, now we want to combine x and y in our own fashion, and we use what was that, merge combiners x comma y. Do you see? And that's for this function too. All right, so we have defined it such that we want to concatenate these values. All we want to do is, given an array of values, we want to concatenate these values and put square brackets around it. That is our objective. Okay, that's what we want to do. We want to create tuple out of our integers, and the tuple at the end of day would have two square brackets at first and last element and all the values in between. Sounds good? So let me try to run it for you. So you can see that it has created an output which is a tuple. Tuple is like an array but with the round brackets around it. And it has 1, 2, and 3 as the values. Sounds good to you? Brilliant. So, alright, alright. So everybody okay with this? Or you need explanation? It has nothing to do with Spark. It is just, I have created these three Python functions and I'm just calling them. Okay, there is no Spark involved in this particular problem. Created three functions. First function converts an integer into a tuple. Second one takes a tuple and adds one more value to it. And third one takes two tuples and merges them. And that's what it does in our own style. Now let's say we do this. We have an RDD with A1, B2 and A3, and we say combine by key, and we pass these same three functions. What will be the output? Anyone? Mehndi, Ashish, Ishwar, Jitendra, Gaurav. What will be the output for this? And this says the output will be A13 and B2. Okay, so it will be just like A13, or will it be in any other format? Okay, so Gaurav, do you think the 2 is going to get combined with 1 and 3? All right. Try, if you want the code, I can give you the code here. All right. So look at this one closely. When we try to do 1, 2, and 3, it combined them to form this. Okay? Same thing is happening here as well. All right. Are you giving it a try or should I move? Great. Great. Yes, that is correct. All right. So that's an answer from Gaurav. All right. Yes. All right. Brilliant. So is it clear to everyone how it happened? So all the values for A will be combined together. And how are we combining? Using our these three functions, CC, MV, and MC that we have defined here. And the way we were planning to combine is we will enclose our values inside these square brackets. Okay, forming the tuple, and first and last element of the tuple is a square bracket. All right. Any doubts at this point? Please feel free to ask. Okay. All right. Sometimes you want to sort your RDD based on the key. Okay. We want to sort our RDD based on our key. For example, and let's say we have this list. We give it TMP, and what we want is we just want to sort it. We want to say sort by key and say collect. Okay, sort by key. Sorry, we have to do sc dot parallelize. All right, now you can see that it has sorted by first numbers 1, 2, and then A, B, and D. Do you see that? So it has sorted our data by that particular key. All right. Sometimes you want to mark it descending, and sometimes you may want to uh, sort it with, let's say you want to mark it descending. Now you can see that D, B, A, and 2 and 1. All right, based on their ASCII value, it has got sorted. right? If you want to make multiple partitions out of it, let's say two partitions, okay? Now you will see that there will be two partitions and both of those are individually sorted. So first partition is having these two values, second partition is having these three values, okay? You can see that it's not because B has, uh, all right, or let me just show you how it happens after the partition. So let me just put it into a variable and we say p dot glom and dot collect. Okay, so here you can see there are two partitions, D and B, and then A, 2 and 1. All right, so we can create multiple partition as well. All right, next we can also try this way. So you can see 1, 2, A, B, and D. Alright. So is the sorting clear? So we talked about two arguments. First one is ascending. And also we can put the keyword arguments here. We can also say that ascending equals to true explicitly here. We can say ascending equals to true and number of partitions, okay, number of partitions equals to 2. Okay, you can also say it that way. That's how the keyword arguments work. Okay, here I think ascending, you can see that. All right, let's move on and let's understand what are the other functions. So we can also pass a function called key function. Okay, key function is the criteria on which we can sort our data. For example, let's say we have got this data called TMP, okay, and we are making an RDD out of it, and we say, all right, where is it? So we will say, why is there an extra bracket? All right, so we can say my RDD equals to sc dot parallelize, and then we can say TMP, okay, and then RDD dot, you can say RDD dot take 2, take 1. So where is the taken one? Yeah, all right. All right. Now let's say we want to define a function such that it is, now if we try to just sort by key just like that, okay, let's say we want to say sort by key and then collect, okay, so what would happen here is it will be sorted but Mary is coming before A, and okay, so to fix that, we can create our own lambda function. We could create our own key function. Key function equals to, either we could define a function upfront or earlier, or we could do it in line using lambda keyword. Okay. So it says lower is not defined on this. Let's see if lower is defined on this. Yeah. Now you can see that Mary has come on the. Also note that Mary is still in caps. Our key function does not alter anything. It just consulted for sorting. So first, a key is converted into another key using your key function. The key of your RDD, the key which is the first element of the tuple inside RDD, that is your key in case of key value pair. Okay. Now that key gets converted into sorting key on the basis of which sorting will occur using your key function. And right now, all it did was convert it into lowercase. So the sorting key was the lowercase instead of exact way. All right. Let's say you want to reverse a string and sort the data based on reversal. Okay. So if you have Sandeep, you could reverse it. Okay. I think what was there was a function called reverse, right? A reverse. There was a function called reverse. Or let's say we want to sort the data based on last three characters. Okay. And how do you find last three characters of anything? By saying minus 3. By saying minus 3. Yeah. By saying minus 3 colon. Alright, so this way you can get the last three characters. And let's say we want to sort the data by last three characters. Okay, so you could return in your key function, in the key function here, you could return x, and let's say lower, fine, and here we say pick up only the last three character and make that as a key. Okay, now you see that based on that, this is the result. Because here A and B comes after A, and ARY comes, ARY comes just after M, and ECE is after that, and HAD is after that, IT is after that, and so on. Sounds good? So this way you could sort your data in whatever way you want. Alright? But you will not be writing compare to operations as you did earlier. Here you will not be writing compare to. Instead, just like MapReduce, you will be giving out a key on the basis of which the data gets sorted. Alright? Sounds good? Sounds interesting? Any questions at this point? If you have any questions at this point, please feel free to ask. Alright. Okay. Sometimes you want to subtract one list from another based on the key. These are the set based operations. Basically, these are sort of emulation of set based operations. Okay, for example, we have one set which has A and B and B and A as the key. Second set is having C and C, A as the keys. Now, what we want to do is, although this sorted is not required, we will take it. This is unnecessarily crowding our space. Sorted is Python function to sort the data. Okay, so all we do it here is x dot subtract by key y. Okay, so irrespective of values, the keys will get removed. So from here, A will get removed. Okay, C will get removed, but there is no C, therefore only B is left. Correct? Sometimes you want to join the two data sets. Okay, so Spark provides you as part of the main API to be the ability to join two data sets. For example, let's say there is one data set A and B. Second data set is this. Also, please note in the previous example that this is not truly a set. This is not truly a set. Therefore, in normal scenarios when you are doing a set based operation, this would result in errors. But here uh, it's an emulation of set based algebra, and it tries its best to fit into the situation. Okay, therefore it will deduplicate it and will utilize the subtraction. Okay, all right. So when you want to join two data sets, it's very straightforward. We just take, let me just remove this sorted function. It's not required here. Yeah. So what we want to do is we want to join two data sets. What does it mean by joining two data sets? Pick up the key from one, find all the keys in another, and then bring the data together. Okay. For example, here, okay, and so 1 and 2 has been joined to form 1 comma 2. 1 and 3 has been joined to form 1 comma 3, while there is no corresponding element for B. Okay, let's try it out. X is this and Y is this, and then we say X dot join Y. Now you can see that you have A 1 comma 2, A 1 comma 3. Okay, for A will be joined with all the A's existing in Y. Similarly, had there been B this side, B could have been joined with all the B's in Y. Sounds good? So these are all key value based join operations. So we can do left outer as well. What does it mean by left outer? All the values from left will go into the output, even if there is no value from the right hand side. So we can say x dot left outer join y. Let me just remove sorted. Sorted is just sorting the output, it's doing nothing else. So we are joining x with y, doing a left outer join in the sense that A and B will go in the output even though B does not have any element in Y. There is no element in Y whose key is B. X is this, Y is this. Now you can see that the B has come in the output, and there is one more element in B. Its name is null. Okay, it just signifies that it could not find corresponding element in Y. Yes, we can definitely join, like if we take this part. Okay, so Gaurav's question is, can we join the data and put it in another RDD? Definitely. So we could say things like this. Okay, so here then we can say RDD dot collect. All right, we could say RDD equals to x dot left outer join and then RDD dot collect. And after collecting, we can put it in a local variable. This is our local variable, and we can apply the local functions of Python like this. Sounds interesting? Alright. Now the other way to represent the same problem of joining two data sets could be this way. So let's say there are two data sets or two RDDs, one RDD, second RDD. Each row is an element and the first column is the key. Now if we say left outer join, what will be the output? Quickly. The same thing what is represented here. SC dot parallelize 1 Sandeep, 2 Shravani and Y equals to SC dot parallelize and 1 Ryan and 3 Giri. So if I say X dot left outer join, what would happen to the output? Quickly. You're doing a left outer join between this and this. In left outer join, all the values from left are searched in the right side. If found, then they are joined together. If not found, then they are if they are not found on the right hand side, they will still go in the output but with one element called none. Alright, Gaurav says it is one. This is what is the suggestion from Gaurav. One. Alright, that's correct. So let's try to do it. Let's try to do it. You can see that? Yes. So the only difference here was, yeah, that this is again inside a tuple and then in the square brackets representing the RDD. Sounds good? All right. Mehndi, Iswar, Gaurav, Hiren, Jitendra. In exact similar fashion, we could join two data sets in a right outer fashion. Okay, so in the right outer fashion, the values from the right hand side will come irrespective of whether there is a value found or not. Okay, so it's equivalent of saying y x dot left outer join is equivalent to saying y dot left outer join. Okay, so here we are trying to join x and y, where we are saying y dot right outer join on x. Okay, the result will be same. So we have x this, we have x this, y this. Okay, and then we are saying, I'm just removing the sorted again because it's not much required. All right, and we are saying y dot right outer join. See that? Y dot right outer join x. Right outer as in x is on the right hand side, y is on the left hand side, and then we are saying y dot right outer join. So all the values from x will come in the output irrespective of what it is. Okay, sounds good to you? Great. In the same way, can somebody help me with this answer quickly? I'm saying right outer join. So on the left hand side, you have one Sandeep, two Shravani. On the right hand side, you have one Ryan, three degree. So when you say right outer join, what will be the output? Quickly. Yeah. Mehndi, Iswar, Jitender, Ashish. What will be the output of this one? We are saying right outer join. Right outer join, which means all the values from right will go in the output, right? All right. Ashish says it will be 1 Sandeep, comma Ryan. Good, good. And then 2 Shravani. No, actually, all the values from right hand side will go in the output. Okay, so it will be 1 Sandeep, comma Ryan. That is correct. And then will be none, comma 3, comma Giri. All right. Yes, good. Thank you, Ishwar. That is how it will be. All right, all right. So, Jitendra, in this case, what would happen is your first answer is correct that it will be one Sandeep Ryan, but two Shravani could have been the case when we were doing left outer join, meaning we want all the values from the left hand side. Here we are saying right outer join. Good. So Mehdi's answer is 1 Sandeep, comma Ryan, comma 2, comma none, comma Giri. Okay. So the only minor modification you need, Mehdi, is that it will be 3 instead of 2. I'm assuming that that's a honest mistake. All right. Here it is. All right. Is this clear to everyone, or have I done anything wrong here? Should I move ahead? All right. All right. So let's take a break and back by 8:46 a.m. IST. All right. All right, should we start now? Hi everyone, I'm back. Should we start now? All right, only Mehdi is back. Gaurav, Ashish, Jitender, should we start? Hi Jitender, should we start now? All right, great. So left outer join, normal join, and our right outer join is clear to all of you? Great. Any questions at this point of time? All right, all right, all right. So sometimes you want to join, okay? You want to co-group the two data sets. Okay. For example, let's say you have A1, B4 and A2. All right. Sometimes you want to group them as well as join them. Sometimes you want to group them as well as join them. Let's see. Let's see what does it mean. Let's create one more thing called A3 and then try to see whether this works or not. Okay. So we have X, you have Y, okay? X is A1, B4, and Y is only A2 and B3, okay? And what you can do is you can say things like X dot co-group, okay? Or let's just assign it to another RDD. So CG is an RDD, okay? And you can say collect, all right? It says that it's a iterable, okay, which means we will have to collect this, okay, we'll have to uh, operate upon each value and clean it up, okay, because it's a what does it do, just a second. All right, so there are two ways to clean it up. So let's just first try to get this data, okay, let's call it cg equals this. Now once we have created once we have created let's say co-group local equals to cg dot collect. All right, now what we have done is we have grouped these values together. For a, all these values 1, 2 and 3 have come together, okay. Now at this point of time, either we can just we can just collect it and do it offline, convert the iterator to something, or Or what we could do is we could convert the iterator into a list of values. Okay. So either we can collect it and then convert, or we could operate on CG and then convert. Okay. Let's try to operate on CG as well. So our CG is X co group Y. So we could say map, and then we could say lambda, and whatever is the object, it would return, it would cast it into the list and form this. Okay, we call it CG1, and now CG1 dot collect. Okay, still it has not given us anything. Okay, so what should we do is yeah, so we should generally say x comma y as this. Okay, so because it's a tuple, and we are going to convert only the second value. Okay, only the second value, cg1 dot collect. No, it did not work still. No, it does not work. Let's try to do something more. So given an iterator, can our function called f, given a iterator or a key and value of x, and can we just return list of v? Okay, so cg1 dot collect. Let's see what happens now. No, it says that it's iterable and we cannot convert it just like that. Let's try to do it in the way we have defined here. We are saying, okay, so we are saying that cg1 or cg dot collect. So what is cg? Cg is our x dot co group. It will bring all the values together and put a iterator over it. Okay. Now, what we can do here is we can say for x, y in, we convert CG into a list. Okay. And then we say, all right, xy in that list, we convert this. Okay. So we are calling list on each value of y. So y is again going to be iterator, and each value of y we are going to call list function on each. Okay, so what is happening? CG dot collect. Yeah, this is good. This is cleaner actually. Yeah. So let's see what exactly did we do. So this is what we did. This is what we did. Okay. So what we did was we said CG, which is after co-grouping, we said collect, and then we printed the result of mapping list on every element. Okay. Now my question is, what if we just try to print y? Y is an iterable. Okay. Or what we can do is here at this point, we could again go with z in y and print x, x, and say colon y. Okay. We'll have to cast it into string. All right. No, no, no luck. Sorry, for Z in Z in Y, we'll have to do this. Again, it is again a list. All right. Do I need to again iterate over this for Z1 in Z? All right. So there is a 3 level of nesting here. Yeah. So you can see that A, 2 and 3, B, 4. So it's a list of lists. All right. It's a group of groups. So that's what it does. It is basically a group of groups. All right. So we could also do things like this. All right. So this is an alternative approach to print the data. All right. Is it clear to everyone? So I'm saying we collect all the records, cg.collect, okay, and then we iterate over the list xyz in the whole list, and then so there is a difference between an iterator and a list. Okay, iterator is basically something which has given you a cursor kind of entry point, and you are getting one element at a time, while list is like an array. You can convert any iterator into list by passing that iterator as argument here. Okay, so first we are iterating over all the values of this RDD. Then inside the RDD, we pick up the values and iterate over all the values and then further. So it's a group of groups. It's a group of groups. You can see this way also, although this sorting is not required. Okay. Okay. So it's a group of groups. This is a better representation of our data. So A is, I think this is a better way to represent. to understand what exactly happened. Okay, so we are trying to co-group this x and y. So A has got 1 and 2 comma 3. So first these are grouped, okay, on both the sides. On both the sides, the A is grouped and A is grouped on both the sides. Then the two are joined, and therefore it's a tuple of two groups. Okay, basically both will be iterator. This will be an iterator. This will be an iterator, and in the same way here also, it's a group of groups. All right. Now, question to all of you is, if you have to convert this into, let's say you are given this kind of an RDD. Okay, this is an RDD which is given to you, and you have to flatten it. You have to convert this into a single array. What will you do? Anyone? Anyone? So we cannot use reduce because our input is an array. This is an array. This is an array. We want to combine them together to make a single list. So say we want to convert, how should I explain? Or let's say we want to sum it up. So in those cases, we will use our combine by operation, combine by key operation. Okay. All right. Now this one, can anybody help me understand what will be the output for this? Yeah, we could also use flat values. Flat values, but will when you say flat values, you know what will it do? It will basically ungroup the things. So again, you will have to group them together. Flat values will not just combine all the value for if a value is a group of things, then if flat values will not flatten them. Flat values will convert key an array of values into multiple elements. All right, what will be the result of this one? Anybody? We had just done a similar exercise. All right, I'm sending you the code. All right. So x dot co-group y, and then collect all the values together. Okay, collect all the values together, then convert that into a list. After you have converted that into a list, what you want to do is you want to iterate over the list, and then for each value of y we apply the list function, and then convert that into a tuple. All right. Yes. So Ishwar, it will be similar to what you are proposing, but it will be like this. Okay. 1 comma 3 will be in one square bracket and 2 will be in a different square bracket. Sounds good to you? All right. Again, if you let's go back to our discussion on flat values. Flat values will basically unfold it. Okay, unfold it. The way grouping happens and grouping groups the values, flat values will create more number of keys. Okay, flat values will not combine these two lists together. Sounds good? All right. So sometimes you want to count the number of elements for each key. Okay, count the number of elements for each key. This can be used as a word count. Okay, this can be used as word count. So you can say sc dot parallelize and give the full list of elements, and then say rdt dot count by key, and items will give you the result. All right. So you can say rdd equals to sc dot parallelize, and then you can also say rdd dot count by key and get the items. You can see that A is twice and B is once. If we add more element to it, like this one, what will happen to the result? Anybody? All right, let me just add. Yeah. So what would happen to the result? And I say rdd dot count by key. All right. So it says that it's a dictionary of type int, and the value is A is 3 and B is 1. Okay. Sounds good to you? Now, please note that this count by key is it's a it's basically count by key is basically an action which brings the data immediately to the driver. Okay, you don't have to. It doesn't return an RDD. It returns a dictionary. All right. Sometimes when you're collecting things from the from our RDD, we want to collect the data as the map. Okay, so that you can operate instead of like an array, you can operate on it like key value pairs, and and therefore it's quite useful. Now for M, if you go, it shows clearly that these are the key value pairs, and it's a hash map. So you could do things like this. Okay. And if you have say proper something like a string key and string value, okay, and if you are collecting as a map, so you could access the element in the similar fashion. Okay, sounds good to you? All right. All right. So when you say lookup by key, it basically return the list of values in RDD for key. Okay. If you have a range of values and you, okay, so you want to look up for something, then you can simply say lookup and then get the results. But if you have the data sorted, the result is very much fast because it uses a way to search, uh, a kind of a binary search to look up the data. All right. All right. So if we have, kind of, we have parallelized the data, and so it has returned us the value. Okay. Just that the it's little slow, as in it has taken around 0.27 millisecond, 0.27 seconds. Now, if we had sorted the data by saying sort by key, and then we look up for data like this, then it will be slightly faster. But the irony is, it is actually, yeah, this time it's fairly faster. It finished around 0.08 seconds. All right. This time it's 0.068 seconds, and so it's less than 100 milliseconds. All right, it's around 10 milliseconds it's taking. All right, sounds good to you? All right, this is something which we have not discussed so far. Okay, so let's say we have the data, as in we have, say, one RDD equals to range 1 to 1000. Okay, sc dot parallelize this. Okay, so I think we have, do we have zip function in future? Anyway, we'll just discuss it even if we don't have. Yeah, so we have this, or let me just say 10. Okay, or say 5. This will be easier. So rdd dot collect. So we have 1 2 3 4. Okay, now let's say there is another RDD1 which has sc dot parallelize, and we have A, B, C, and D. All right. So we have RDD1, which is that we can see if it is working or not. Okay. A, B, C, D. Perfect. Now let's say we want to zip these two records together. Okay. Sorry. So rdd.zip rdd1. Does it work? Let's see. Yes, it does work. So, and if you see what do we have here, you can see that it had zipped two records together. Make sense to you? All right. The zip function is also part of the standard library of Python. Okay. where it combines two lists exactly in the same way. Our zip function has combined the two RDDs. Okay, zip function acts in that fashion. Or you can have a simpler example, say zip 1 comma 2 comma a, and let's say this. All right, so it has only combined 1 and a, and if you want to zip these together, does it make sense to you? It's basically combining first element of one array with first element of second array, then it's combining the second element of first array with second element of second array, and so on. Okay, in the same way, the same thing applies to RDD as well. All right, and this is what is happening right now. So what we have done is we have created 1000, we have taken 1 to 9999, and then we have divided it into, after combining it with itself. If you look at this, if you have, let's say, 10, and we are saying zip L with L. Okay, okay, so we have combined it with itself. Or we could further go ahead and say L1 equals to map L with lambda x and x plus 3. Is it the first element or second element? Yeah, so you can see that L1 is this. We can zip L and L1 together, and now you can see L is this, L1, L1 and L are these, and when you zip them together, this is what you get. All right. Now, once we have done that, we tried to look up. Although there were 10 partitions, it the process was slower. But the moment we did sort by key, the lookup became really, really fast. It became 10 times faster in for our data set. All right? Around 10 times faster, not really 10 times, but yeah. All right? These were the most common operations on paired RDD. Now let's discuss something about data partitioning. So, how many of you know about indexing in the databases? Gaurav, Ishwar, Mehdi, Jitendra, Ashish, Ishwar, Hiren. So, are you aware about what is the indexing in databases? Ishwar and Mehdi are aware. What does it mean when we say that we have created an index on a table? Great, great. So, So when we create indexing, what exactly happens in the background is the data gets sorted and a separate list is created, just like just like the way we prepare the index on the back of a book. So on the back of a book, you will see the index, as in for each keyword, there is a back reference to the book saying that this particular keyword was found, this particular word was found at this particular page. So that's an index. Yes, that's correct. Ishwar. Ishwar's answer is that in order to improve search based on a key, we use indexes. Perfect. So similar to indexing in databases, here we have data partitioning. So when we have to you do some operations on RDD which are lookup intensive, such as joins, then it makes sense to sort some data and create sort some data and do the partitioning, to do the join and other operation. And that process is known as data partitioning. All right, there is no overlapping ranges basically. So data partitioning helps us minimize the data transfer. As we all know that in case of big data, the main problem occurs when our data is being transferred over the network. So we need to figure out all possible ways to avoid or to minimize the total data getting transferred over the network. Okay, we need to minimize the shuffling efforts. That's what we did in case of Hadoop's MapReduce, and that's what we are also trying to do here. Jitendra says that that's not true in all databases. Yes. All right. So, what is not true? Which sentence are you referring to? You mean preparing a list of values and sorting the data? Yeah. So, listing techniques, the indexing technique might be different internally. For example, in case of MySQL and other databases, the the way it indexes is it's creates something called a B tree, okay, and then indexes the data. And I think in another one somebody uses B plus tree. So under the hood the strategy might be different, but the behavior is that indexing means we take all the values of a column, order it in some way, and make it such that when somebody tries to look up look up a value for that column, it is immediately available and we know which column contains that value. All right, so you do the data partitioning to lay out data such that the data transfer becomes minimal. Now in case you just want to do the search or do some operation only once, then this is not really useful. It's like sorting the data and only for looking up once. Okay, if you are sorting data multiple times, only once and looking up multiple times, then you will see the impact. Because when we just now sorted our data using sort by key, it took around a second. Okay, if we had to do only one operation, why would we put this additional effort? Okay, it's very helpful when the data set is reused multiple times in key oriented operations, and this data partitioning is available for all the key value RDDs. So it causes the system to group elements based on the key. All right, it basically forces the system to to to, to bring all the keys together whose codes are matching. All right, so it tries to group or bring the data together. Group as in it doesn't impact, it doesn't change the layout of our RDD. It basically just brings data together based on certain parameter. Okay, and Spark does not give explicit control which worker node has which key. Okay, you do not have a explicit control that which node is going to get which key, meaning you do not manually put one particular key on one particular partition. All you do is you define a partitioner function and hand it over to Spark, and Spark will reorganize the data according to your hash function or partitioner. It lets program ensure which set of keys will appear together based on some hash key. For example, you could do a range sort. All right. So so basically, it lets you force Spark to bring certain data together based on a hash key, for example. All right. And you could also do sort of range sort, as in basically when you have to sort the ranges, then you generally use those kind of functions. All right. All right. Okay, so Jitendra meant by the indexing's definition is not true in case of all the databases, and he meant that for example, in case of Teradata index is used for distribution of data on EMS. All right. All right. So you mean the bucketing or the distribution of data is something for which indexing is also used. All right, good. Now the example of I'll just take a real world case a scenario of data partitioning example. Let's say you have two data sets. The first data set is user data. And what does this user data have? Okay, let's say you are running a website in which you are noting down the behavior of the user. Okay, and your objective is to find out continuously what are the elements user is clicking which are not part of his subscription. Okay, you want to identify what are the elements which user is interested in which is not part of the subscription. Okay, so let's say you are visiting certain news website, so you will have something called subscribe topics. And other than that, you might be visiting other news items which are out of your subscription, as in out of your subscription choices which you have already made. Now we have to find that out for all the users continuously, almost in real time. Now what will be the way? Let's say you have an RDD representing user data, and this RDD contains two columns called user ID and user subscription topic info. These are the pairs, basically key value pair RDD. And user subscription topic info is a list of topics. So we need to periodically, maybe at the end of every day, we need to combine user data with last 5 minutes events. Or let's say every 5 minutes, we need to combine this user data table with the last minutes table of events. And events is something like events contain two columns, user ID and link, on which link the user has clicked. Okay. All right, and this events table, because it's just 5 minutes data, might have very small information, while user and user subscription topic info can be quite huge. Okay, therefore Therefore, we have one table called user data, which is very huge, and other table called events, which is very small. And we have to keep on joining these two data together continuously in order to meet our objective. And the objective is count how many users visited a link that was not one of their subscribed topics. how many users are visiting the list that are not part of our subscribe topics. Now, to do that, basically we have to continuously find out how many people, how many users are having the events mentioned in the events table, which is not there in case of user data. All right. So to do that, I would go this way. All right. If we have to use our Python code, we might have to uh, first create a Spark context object. Okay. And then we read the file of user data and persist it at this point. Now, at this point, we are persisting it. As soon as we have read the data, after reading the data, we are persisting it in the memory right now because we are not providing other argument. And then in the function called process new logs, we are given a new file, new log file, which is basically last 5 minutes events. And we are joining user data with events. Now, if you notice that every time we will try to join it and we try to access our data, what would happen is we will keep on we will keep on shuffling the data, or the structure will look like this. This is our user table, this is our events table, and while joining, some of the keys will go here, some of the keys will go here, and so on. So the shuffling efforts will be really high. Shuffling efforts will be really high. All right. And here, what we are doing is, after we have joined the records, we are applying a filter. We are saying, find out all those user IDs which do not exist in the link info dot topic. Okay. And then count that. Then count the RDD, and that will be off topic visits. Now, in this, everything is good, logic is good, but it will be very inefficient because there is a lot of network transfer involved in joining the two data sets. To avoid it, to avoid such kind of data transfer, you will have to mark the joined data. You have to take the user data and mark it partitioned. You have to partition it. Okay, you remember our function called partition by. So using partition by and so using partition by default considers hash code. All right, it by default considers hash code and it will persist the data. Okay, partition by makes sure that the data would come together based on the key. And when we have, because whenever we are joining the two data sets on the key, and one of the data set is already sorted by the key, then the shuffling efforts will be very less. As very obvious from the data set, the user data is not being moved while joining. Okay, only the data from events table is being moved. All right. So what you generally do is, whenever you have huge data and you have small data, so you partition your huge data such that only the small data goes to the corresponding RDDs and will get joined. Okay. Instead of shuffling being on both sides like this scenario, okay, the shuffling efforts will become very less. All right. The dash dash dash, the uh, line with dashes, is the one which represent the local data transfer, and the strong lines represent the network data transfer. Sounds good to you? All right. Sometimes if you want to determine if you want to determine whether an RDD is partitioned or not, just check just check the partition by function. Okay, just check the partition by function and you will get the answer. All right, so where were we before this one? Yeah, so let's say sorted is partitioner. All right. So since the sorting itself creates the partitioning actually, internally sorting creates the partitioning. Therefore, it has a partitioner object. While if you try some other data set, say RDD, so RDD, let's say partitioner, it doesn't have a partitioner. Partitioner. It doesn't have a partitioner. So the moment you either sort or you say partition by, a partitioner is created, and whenever you are joining a partition data set, you will always get very good and efficiency. All right. So these were the two aspects of making the data lookups fast. So the partitioner impact all kinds of operations where the shuffling is required. Shuffling is required in case of co-group, group with, group by key, join, left outer join, route outer join, combine by key. Okay, and lookup. If you have to customize this partitioner, then you can customize in the following way. You can create a function which takes a value and returns a number, returns a hash value. That's all. And then you can pass that as the second argument to partition by function. All right. Any questions at this point? So this will create 20 partitioner utilizing this particular function which we have just defined. All right. All right. So again, it's a page rank problem. So how many of you know what is a page rank problem? Anybody? Have you ever heard about something called Google PageRank? All right. So let me give you a brief history about PageRank. So the reason why Google got started, why Google became the best search engine, it was because of the PageRank algorithm. And the way they started ordering the result is based on the PageRank. And the PageRank was not because of number of keywords or or the keyword density. The PageRank was because of how many people are referring one particular page, how many backlinks are there, as well as how many quality backlinks are there. So people with good page rank, people with good page rank, sorry, pages which are getting the backlinks from other pages that have a good page rank gets really good overall rank. And the way it happens is that, okay, so I will try to draw it. All right. Yes, that's correct, Gaurav. PageRank is the basis of hit count. All right. So the way PageRank is computed is in the following way. Let's say there is one website called W1, W2, W2, and W3. Okay. They are linking to, say, Wikipedia. All right. And so this is the Wikipedia, say W4. So W1, that is your website, that might be your website, is having href to W4. W2 is also having href to W4. And there is some other website called W5. Okay, W5.com. And W4 is also referring to W5, and W3 is also referring to W5. Now, because of this referring, what happens is the W5 will get the highest page rank. Okay, W4 will get more page rank than W1 and W2, and W5 will get more page rank than W4 and W5. And the way this contribution works is in the following way. Initially, every page's rank is 1.0. Every page get 1. Okay, every page get 1.0, 1.0, and 1.0. All right. Initially, that is how the system starts computing. So these are the websites, they are linking to each other, and they are given these ranks. All right. On each iteration, every page P sends contribution of rank of page P divided by number of neighbors of P. Okay. So how many neighbors does it have? 1, right? And 1 plus 1, 2. So his page rank, sorry, so sends a contribution to its neighbors. Okay, as in if it is referring to one more website called W6. Okay, and so in this manner, what happens is W1 will give contribution of its base rank, which is 1, to this one, point 0.5. We will consider this problem again when we are talking about graph. Okay, so I'll just in the first iteration everybody is at 1 0. Okay, and let me just copy this to a new one. All right, so that was the first one. What happens in case of in the second iteration, since W1 is giving its weightages, because W1 is referring to W6 and W4, W1 will give a rank of zero point 0.5 to this and zero point 0.5 to this. Similarly, W2 will give zero point 0.5 to this, and the W1 will give actually 1 because it doesn't have any other to report, and this will give 1 here. So effectively, the total contribution W4 has received is 1.5, right? W5 has received a total contribution right now. This one is 1.0. Okay. Total contribution W5 has received is 1.0 and 1. All right. Now, after this, there is a calculation that happens to update the page rank. The calculation is 0.15 plus 0.85 into contributions received. It got a contribution of 1.5. W4 received a contribution of 1.5. So its rank would be 0.15 plus 0.85 into 1.5, right? Which means it becomes something of the sort 1 plus zero point 0.5 into this, which is 0.425. All right. So the total rank of W4 has become 1.425. All right. So if you notice that W4's rank has improved, and so is his. So what will be his rank? 0.15 plus 0.85 into zero point 0.5, right? Zero point 0.5, which is, it will become, all right, 0.5 plus 0.85, and the overall rank will be 0.55, 0.54525, something of that sort. Let me just try to do it again. It will be 0.15 plus 0.425. Okay, so that will be 575. All right. Now, the same thing applies to them. How much contribution they did receive? It received zero contribution. So its value goes down to 0.5, 0.15, its value goes down to 0.15, and its value goes down to its value goes down to 0.15. All right. Now, so as you notice that as we are going ahead, all the values are changing. But if you run this iteration multiple times, these values will stabilize. Okay, so the page rank values will stabilize if we go through multiple iterations. Also, one more thing you should notice here is that next time when the next time when the contributions are received by W5, what will happen is its contribution will be 0.15 plus 0.85 multiplied by summation of all the contributions received is 1.425 plus 0.15. This is the contribution that you will receive, that W5 will receive. Effectively, W5 will have the highest page rank out of all. Okay, so as we keep on moving ahead, you will notice that the highest page rank anybody would have is W5, because W5 is being voted by so many people. Okay, and as the iteration goes, these values will keep on getting updated again and again. Okay, so the base rank is computed multiple times, and every time there is a change in everybody's page rank. Sounds good? Is the algorithm clear to you? This formula is 0.15 plus 0.85 into total contributions received, and the contribution is a particular record, a particular page's rank divided by how many contributions it is giving. So this is the algorithm, and you have to compute the page rank. All right. So can you do this page rank algorithm tomorrow? Imagine two data sets. So imagine that you are given a link like this. Okay, you are given the textual representation of this graph. Let's try to build that. So W1 is linking to W6. Okay, so we have an RDD in which first element is W1 is linking to W6. All right, the second is W1 is also linking to W4. All right, W2 is linking to W4, all right? Or you can just represent it like this. First element is the one which is voting, and W4 is linking to W5, all right? And W3 is linking to W5. This is what is given to you. This is the only thing which is given to you. Okay? And you have to find out the various page ranks of W1, W2, W3, W4, W5, and W6. All right? W1 is waiting for is voting to W6 and W4. W2 is voting for only W4. W4 is voting for W5, and W3 is also voting for W5. Okay, this is the graph which is available to you. This is the RDD which is available to you. Now your objective is to find the page rank of each element. Okay, can you do this computation what we just did for this kind of data set? Can you? Is the Google PageRank algorithm clear to you? Because that's probably one of the most important reason why most of the data sciences get discussed. Okay. So various pages are giving votes to various other pages, and that's happening recursively. Okay. So your objective is to compute the page rank. The way we were doing it manually, please compute it using the technique. Okay, imagine this is the data set available to you. Okay, this is the data set available to you, and rest you have to compute their page ranks. All right, let's talk about this tomorrow again, and we will go through our approach and we'll discuss in the detail. Oh, not tomorrow, next week. All right. All right, let's move on to another topic which we have been planning to discuss. All right, will you be able to do it, this page rank algorithm? All you need to do is you need to compute the weightages. First, assume the values of all the nodes to be 1. Okay, and then start voting and keep computing. Okay, and do it multiple times, maybe 20 times, and you'll get the answer. All right. All right. Now, so far we have been loading the data from text files and HDFS files. Loading the data in Spark is possible from variety of sources. This is something which probably every system needs to work upon. Okay, whenever you build a database, you build a import from almost all the data set. Otherwise, nobody is going to adopt your database. Similarly, Spark did a very great job at importing data from multiple data sources. All right. So far we either once loaded the data using HDFS file, or we converted in the in-memory data. Spark provides a wide variety of datasets and can access data through input format and output format. Those were the interfaces used by Hadoop to talk to the file system. And interestingly, input format and output format is something that has been widely adopted even by S3 Cassandra, HBase, and MongoDB. So therefore, Spark provides you the data input or output from from NoSQLs as well as the big data systems. Along with that, it provides you the support of loading data from relational databases. So you can import various kinds of file formats such as text, JSON file, sequence file, object files, protocol buffers. We will go through these list of these formats, and you can also configure compression. You can load the data from various file systems such as local, NFS, HDFS. NFS is network file system, HDFS, Amazon S3. You can also load structured data through Spark SQL and run the various queries. And you can also load the data from key value stores such as these NoSQL databases and others. All right. Now, text file is plain text. These are the file formats. Let's start with the file format. So, text file is a plain text files. Records are assumed to be one per line. JSON is a common text-based format to represent complex object. Most libraries require one record per line. All right, keep that in mind. CSV is comma separated values. There are many comma separated values, including Excel and others. And there is a sequence file. Sequence file is a very common format in case of Hadoop for for processing data in the form of key value pairs. Then you have protocol buffers. Protocol buffers is a fast, space efficient, multi-language format similar to thrift object. Now last is the object files. All right. So we'll discuss this part. And so the way you load the text file is very straightforward. You can load the text file like this, saying input equals to sc.text file, and you can read the data. Also, you can read the full directory in a single shot. In a very simple way, you can simply specify the directory name by saying sc, that is Spark context, which is available to you, saying sc.whole text file and provide the folder, and you will get this data. All right, you want to try this out? Let's say, all right. So there is a folder. Did we have? All right, let me just Control Z. Control Z means pausing something. All right. So, okay, there is an indent error. No worries. Let me just clean it. All right. So here, what does it say? I think it's not allowed. Invalid input. Input path does not exist. Home, student, Asgiri. All right, because it was local folder in some other system. Okay. So you could go to Hadoop 1. Hadoop 1. I'm using another account for time being because that's the password I remember. All right. All right. So it's loading the data, and you can see that it has loaded it as an RDD, the list of files. Okay. So what have I done here? First, I loaded all the text files into this particular RDD. Now, when you load the whole text file, it loads it as key value. Key is the name of the file, and value is the content inside the files. Okay, now I have done map values and converted each file string, which is because whole file was read as the whole text, we have converted into the length, okay, length of the file. And this is what it is showing. It is showing us that how big each file is. All right, if you want to see, if you want to see what is going on, so you can say ls minus l, and these are the all files that it has loaded in the single shot. All right, it has loaded all these files in a single shot. If you want to save the results as text file, you can simply say result.save as text file into the output directory. Okay, it will be saved into the output folder. This is an RDD, result will be an RDD if you want to save it. Alright, is this clear to you? This is how you read plain text file or the directories in the plain text format. And also this is how you save the files in this manner. Okay, you can quickly save this length. Okay, you can say length dot save and can say my file. Alright, save as text file. Okay, and here cat my file will have the directories that are required. Okay, you can see that it basically created two folders or two files containing our output, one per partition. Okay, so since our when we loaded the data, our RDD might be having two partitions, therefore it has created two RDDs. Okay, you can see that 0000 and 0001. All right, now this is how you save to a folder. This is output directory, not file. Okay, now if you have to load JSON structure, you can load the full text file and then map over the values with the JSON. So because JSON at the end of day is plain text file. Okay, you can, there are two ways to load JSON files. First, loading it as one line per per RDD element, okay, or full file. Either of them is fine. If your JSON object, the JSON file is very huge, then load it as one line per RDD. If it is very if it is very small, then you can load the whole file and then convert it using the JSON library provided by Python to you. Okay, so we will discuss JSON file format in the next week. I hope that's okay with you. All right, and please work on the page rank part. It's difficult, but yeah, if you give it a little shot, it should be easier. All right, thank you very much. We'll see you on next week. Bye bye. All right. All right. Thank you, Ishwar. Thank you, Jitendra. Thank you, Gaurav. Thank you, Hiren. Thank you, Mehdi. Have a great day ahead. Thank you, Ashish. All right. Bye bye. Have a nice week ahead.